video we will see what is the rate of growth. Rate of growth is the rate at which the running time increases as a function of input is called rate of growth. What does it mean? In the previous video we have seen that the input is increasing the running time. Let's say we are increasing the number of inputs by 10 by 10 and the running time is also going to increase, right? So let's see this thing by an example. Let's say we are going to purchase two things in a day. First is the car and second is the cycle, and we purchase both the things on the same day, and at the end of the day we are going to calculate how much expenditure is done on that day, right? So when you are going to calculate the cost of both things, cost of car and the cost of cycle, you will see, which is obvious, the cost of car is higher than the cost of cycle. So if you are going to see the approximate value, the cost of car is the actual expenditure of the day, right? Because the cost of cycle is almost negligible as compared to the cost of car, right? So this is what we are going to do inside the rate of growth function. Let's say we are having some functions which is in the form of n raised to power 4, 2 raised to power, sorry, 2 into 2, n raised to power 2, and 100 into n and 500. So these can be the values for some functions, and these are actually defining the cost of some functions, right? And what if these all the values are there? Let's say uh, n raised to power 4 is there, 2 into n raised to power square is there, and 100 into n, and all these values are the actual value as we added all these values for a single day. Similarly, for a single program, I wrote an algorithm and all these are the values, the collective values, right? So if I'm going to calculate the actual value, you should say the running time. So in that case, I will take this n raised to power 4, because if I'm going to calculate all these values, this value is actually defining this function, right? So approximate cost of that function is defined in this term, n raised to power 4. So if I'm going to take the rate of growth of different values, let's say there's just 500 into you can say 1, and here 1 means n raised to power 0, right? So if there is n raised to power 0 which is 1, and n raised to power 1, 2, and there can be n raised to power 3 also, and so on. This is how the values are, right? So if we see in this chart, which is useful for you, so here if there is n raised to power 0, or you can say the 1 is there, then the value is constant, right? And if the values is log n, then it is logarithmic value, right? N is the linear value, and n into log n is the linear logarithmic. N raised to power 2 is the quadratic, and 2 raised to power n is exponential. So these are the basic things we are going to use in the rate of growth, right? So you must know these terms so that when we are going to compare the algorithms, you should know what are these values, and because we are going to write these terms there, right? Also these, but if you are going to talk about the cost in actual terms, you are going to say the rate of growth was constant, right? If you are writing 1 means it's a constant, and if it's log n means it's a logarithmic value, right? So in the upcoming videos we are going to learn further. Okay.